A certain iron wire is heated to a certain amount of temperature, and we are asked to calculate its resistance when its temperature is 0. Before we delve into this, we need to understand the parameters of the question and then know how to apply them appropriately. So the first thing we need to do is we write a solution, and after writing solution, we bring out the content of the question. That's the first thing we need to do. So the first thing, look at this. This is resistor R1. The resistance of the wire R1 is 20 ohms, right? And this resistance is taken when the temperature is 18 degrees Celsius. So T1 is equals to 18 degrees Celsius. Okay? So when the temperature is 0, when the temperature of the iron wire is 0, that is theta naught, the temperature is 0 degrees Celsius. Therefore, the resistance of the iron wire at this point is unknown. Okay? The resistance is unknown. So we need to find this. This is the first thing we need to know. Also, we have another one. This is theta 2, okay? And then this is the temperature coefficient of the iron wire. Very, very important. Okay, so theta 2 is also 60 degrees Celsius, right? Since we know theta 2, that means we need to find resistance of the iron wire. That's the second resistance, which is the R2 is equal to unknown. Okay? So these R2 and the R0. R2 is the resistance of the wire when the temperature is 60 degrees Celsius. Okay? Then R0 is unknown, is the resistance of the wire when the temperature is 0 degrees Celsius. Now let's read the question. The question is, the resistance of a length of iron wire is 20 ohms. Good. At 18 degrees Celsius. Estimate the resistance if the wire cooled to 0 degrees Celsius and subsequently heated to 60 degrees Celsius. That's what we are asked to do. Now, the hint here is that the temperature coefficient of iron wire is given at 0.006 per degree Celsius. All right? Very, very important. So what do? We take note of this. Very, very important. And the formula we are going to use, we state our formula as this. The formula we are going to use is very simple. We are going to use R1 is equals to R0 bracket open 1 plus the temperature coefficient of the iron wire and then theta 1 bracket close. That's the formula we're going to use. Alright? The formula we're going to use also for the second one, R2, is also R2 is equal to R0 bracket 1 plus temperature coefficient of the iron wire and then theta 2 bracket close once again. So if we understand this, then we are halfway solving the problem. So if you have watched up to this moment and you have found value in this, subscribe, give us some thumbs up, and then share with your networks, with your learners, with your students, with your friends. Don't forget to put on the bell button for constant notification each time content like this is uploaded. You will be among first set of individuals to be notified. Alright, having said that, let's delve into this properly, into detail, right? Okay, so having said that, let me see that 1 is giving us R0, bracket 1 plus temperature coefficient of the iron wire and then theta 1 bracket close. Alright? So we are going to make R0, okay, because that's the one we are looking for. That is the resistance of the wire when the temperature of the wire is 0. So we make R0 is subject. It becomes R1 all over bracket open 1 plus temperature coefficient of the iron wire multiplied by theta 1 bracket close. That is it. Okay? So the next thing we substitute. We substitute accordingly. For R1 we have 20 ohms. So we substitute for R1 20 ohms all over bracket open 1 plus, this is plus sign, okay? For temperature coefficient of the iron wire, we substitute 0.006, okay? And then for theta 1, we have 18 degrees Celsius and then bracket close. At the end of this, if we simplify this, 20 divide 1 plus, we simplify this, we are going to have the resistance of the wire when the temperature is 0, that is R0. R0 is equal to 18.05 ohms. So this is actually the resistance of the wire when the temperature of the wire is 0 degrees. So we have found that this is the resistance of the wire when the temperature is 0 degrees Celsius. Good. Now let's look at this. We need to find this. Look at this. We need to find this. The resistance of the wire when it is heated to 60 degrees Celsius. So that's another thing we need to find. Okay? Alright, so we have R2. We're going to do that this way. R1 over R2 is equal to R0 bracket 1 plus temperature coefficient of the wire, okay, theta 1 bracket close, all over R0 again, 1 plus temperature coefficient of the wire and then theta 2 bracket close. So with this, okay, so we are combining the two. Of course, this we have to cancel this, and we are left with this. Then we make it R2 the solid. It becomes R2 becomes. We make that the solid. It becomes R1 bracket 1 plus temperature coefficient theta bracket close all over bracket 1 plus temperature coefficient theta 1. So with this, we are making progress. Alright, so what do? We substitute, okay? We substitute. But before we go into substituting, once again, if you have watched up to this moment and you have found value in this, you have been educated in this, alright? Consider subscribing. Give us some thumbs up, alright? Share with your friends, with your networks, with your students, and then put on the bell button for constant notification. Thank you for doing that. So let's solve the remaining part. The remaining part is what we're going to solve now. So if we do that, we will arrive at something concrete, something tangible here. So we now have that our R2 is equal to, for R1 we have 20 ohms, bracket 1 plus, and then 0.06, 006, we have two zeros, times 60 degrees all over bracket open 1 plus 0.006 times 18. Okay, so that's what we're supposed to have. So by the time we clarify these things, by the time we finish all this, we will arrive, if we simplify further, we're going to have R2 as resistance is equal to 24.55 ohms. So this should be the answer. Alright? So that is it. I want to stop at this point, and I thank you for watching to this point. Don't forget to subscribe, share, alright? Put on the bell button for constant notification. See you in my next class.